This is 3 steps to sketch for essential functions. And we're going to do an overview where we look at 2 different methods you can use to get sketches for your graphs. You can use a table or you can sketch on the graph. So both have their merits. Tables are really good for more complex graphs, for people who really like to see the numbers and then to just plot the final points. Whereas the OntheGraph method is usually a little bit quicker once you get the hang of it, and it's really a good method for those of you who are very visual. All right, so let's first take a look at our table method. So 3 steps. 1, first you analyze your transformations. 2, make a table that has the parent points of your graph. And then you'll apply all the transformations from step 1. So each new transformation, you'll create a new column. And then finally, you'll plot your points, your final points. These will be the ones in your outermost columns. And then you'll sketch in the finished graph. So easy enough. Let's see how this works with an example. Okay, so we have a graph given. This purple graph is y equals f of x. And we want to find y equals 2 times f of x minus 6. So let's apply our 3 steps to sketch method. First step, let's analyze our transformations. So I always like to start with the horizontal transformations, and we see that's what's happening in the parentheses here. So think solving order. X minus 6 tells us that we should be moving 6 units to the right. Okay, so, and we only have 1 transformation. I'm still going to label it number 1. We're going to go right 6, or your x is plus 6. If it helps you write x plus 6, you can do that. Okay, and that's our only horizontal transformation. So now let's record our vertical transformation. And we see that happens on the outside here. It's that 2 in front of our function f. So our first and only, in this example, vertical transformation is to stretch our graph by a factor of 2. So that really takes our y's and multiplies them by 2. All right, so now we can create a table and apply these transformations. This is step 2. All right, so let's record our points. Working from left to right, we see our first point is negative 4, 0. Our second is negative 3, 3. Our third is negative 2, 1. Our fourth is negative 1, 3. And our fifth is 0, 0. So let's go ahead now and apply our transformations. Starting with our x, we know we're going to move right 6, or we'll add 6 to our x's. All right, so we can just calculate that. Negative 4 plus 6 is 2. Negative 3 plus 6 is 3, and so on. Okay, so that's taking care of our horizontal transformation. Now we can go on to our vertical transformation. So that's to multiply our y's times 2. I'm just going to write 2y. All right, so 0 times 2 is still 0. 3 times 2 is 6. 1 times 2 is 2. And so on. Okay, so we have our table, we transformed, and now we can plot our final points and sketch in the graph. So our final points are coming from our outermost columns. Okay, so our new point, our final transformed point that's on our graph, 2 f of x minus 6. Our first point is 2, 0. Our second point is 3, 6. Our third is 4, 2. Our fourth is 5, 6. And our final point is 6, 0. So you can follow these points. Let's try to draw that line a little bit straighter. You can follow these points as we did. It's nice. You can see our first point here transformed into the final point 2, 0, and so on. But you can definitely see that our green final graph resembles our original, but it's been shifted right 6, and it's been vertically stretched by a factor of 2. So this is a quick example to show you how to use the table method, and I will probably post another one that has a more advanced transformation where we use the table method. But for now, let's go ahead and move on, and we're going to look at our OntheGraph method. All right, so there are still 3 steps. Our first step is still to analyze the transformations. Step 2, we'll lightly plot the parent function points. And so this is specifically if you aren't given a graph. So if you're just using a parent function, you'll plot your original points. And then you'll apply each transformation from step 1. And you'll sort of do this one step at a time. And you'll have some lightly sketched intermediate graphs. And you'll see more what I mean when we look at an example. And our final step is to darken your very final points so it's clear what your finished graph is. And you'll sketch in to connect all your points. So let's give it a try. Before we do, know that this method does take a little practice, just in terms of seeing how each point moves. But it does help you with your visual skills, and it usually is more efficient in the long run. All right, so we have our method on the left, and we're given that graph on the right, and we're going to find the same graph that we did with our table method, and so that way you can have a nice comparison. All right, but let's go through it pretending that we have not done this already. Okay, so looking at our equation, we see that we have a horizontal transformation, x minus 6. Okay, so remember, think solving affects the x's for our horizontal transformations. So we know that this is going to move us right 6. Or our x's will move 6 units to the right, plus 6. And our vertical transformation is this 2 out front. It affects the y's. What you see is what you do. That's going to stretch us out in a vertical direction by a factor of 2. So we'll take our y's and we'll multiply by 2. So I'll just write 2y. All right, and so we don't have to plot because our graph was given. Remember, you will have to plot if you're given just an equation for one of the parent functions. But now we're ready to transform. So we'll go one transformation at a time and plot intermediate graphs. So let's start by applying our horizontal transformation. We're going to move right 6. So start with that first point, negative 4, 0. And let's count 6 units to the left. 1, 2, 3, 4, 5, 6. And I'm going to put, instead of a light mark, I'm going to draw an X in my blue pen so you can see that this is an intermediate graph. It is not the final graph that we're working toward. Okay, so let's go ahead and move each of our points 6 units to the right. And I'll keep marking with these intermediate X's. All right, so we have our intermediate graph. And we see we still have one transformation to apply. We want to apply our vertical transformation here. So now we're going to multiply all of these intermediate y's by a factor of 2. And once we do that, since that's our last transformation, we'll be able to move on to step 3 to darken the points and sketch in the graph. All right, so starting with our first intermediate point, we want to multiply the y times 2. Well, the y is 0, so our final point we're now going to plot in a large green mark. Okay, moving on to the second point, that y is 3, and it's being multiplied by 2. So stretch it up by that factor of 2, and you've got a final point. Third point, take the y, multiply it by 2, darken the final point. The fourth point, the y also becomes 6, and the fifth point, the y was 0, multiplying it by 2 keeps it at 0. And so we have our finished graph. And you can see that this is the same graph. We arrived at the same solution that we did from our table method, but we didn't have to draw out the whole table. And so especially for a transformation like this, I think that eventually we can get to the point of just kind of doing a transformation on the graph. And you may not even have to mark, if it's just as simple as 2 transformations, you may not even have to draw marks for your intermediate transformation. You can just kind of hold your pencil and do 2 transformations at a time. Completely up to you. I'll post another example of an advanced version of this on the graph method so you can get a little bit more practice. But for now, this was your quick look at the 3 steps to sketch for essential functions with the table method and also with the on the graph method.